Hello again, welcome back. For this video, we're going to talk a little bit about negative exponents. You can see our goals here are to simplify expressions containing zero and negative exponents, and then of course simplify expressions containing just negative exponents. Now we only have the one vocab, so I went ahead and defined it here. Negative exponent, any non-zero real number that is raised to a negative power. Okay, so here's the zero exponent rule. You need to just commit this to memory. The rule says any non-zero number, so a base number that's not zero, raised to the zero power is equal to 1. So a to the 0 is going to equal 1. 30 to the 0 is equal to 1. 5 times x squared raised to the 0 is still equal to 1. All right, so we got a couple examples here for zero exponents. We want to simplify each. Well, the first thing you'll notice is you got a 0 on the outside and there's parentheses around the entire fraction. So it doesn't matter what happens inside. Whatever comes out is going to be raised to the 0 power. So this whole thing just equals 0. Now you got to be careful down here. The only thing raised to the 0 power is the b. So if I simplify this a little bit, I get a to the 4th times. Now b to the 0 is 1, so I'm going to put a 1 there. And I still have an a to the 2nd. Now this 1 is no longer needed. It's just an identity. But I can simplify this a little bit further, and that would give me a to the 4 minus 2 power, which is a to the 2nd power. So this whole thing reduces to just a to the 2nd power, a squared. Okay, so now we're getting into the negative exponents. So here's what the rule says. For any non-zero number a and any integer n, so for right now we're going to assume the exponent is an integer. A to the negative n is the reciprocal of 1 over a to the positive n. That also means the reciprocal of a to the negative n is 1 over a to the positive n. So if I got 3 to the 5th power, that's the same thing as 1 over 3 to the positive 5th power, which of course 3 to the 5th is 243. We saw that in a previous video. So this ends up equaling 1 over 243. So 3 to the negative 5 is really 1 over 243. Now you can reverse that as well. So if I have 1 over m to the negative 2 and it's already in the denominator, well then I can switch that out of the denominator like this and call it m to the positive 2. Now something that's really important here, an expression is considered simplified when it contains only positive exponents. Each base appears only once. There are no powers of power. And then, of course, all fractions should be in simplest form. Okay, so we want to simplify, again, assuming the denominator is not equal to 0, because you can't divide by 0. So I'm going to break this apart and make it easy to see. So the first one is a to the 3rd. There are no a's on the bottom, so I'm going to put it over 1, times. There are no c's in the numerator, so I'm going to do 1 over c to the negative 2, times. And b to the negative 4, I want to make a fraction out of it, so I'm going to put it over 1. Okay, so the first one right here, so I'm going to just leave that as a to the 3rd over 1. Okay, now the middle one, I'm going to times, the middle one here has a negative in the denominator, so to make it not negative, I have to take the reciprocal of that, which would just be c to the 2nd over 1. Then this third one here has a negative in the numerator, so to make that not negative, I got to take the reciprocal of that, which would be 1 over b to the positive 4. And the final solution is just to multiply these things back together straight across, so I end up with the numerator of a cubed c squared, and I don't need the 1. Now, the bottom, 1 times b to the 4th is just b to the 4th. So this right here ends up being our final solution. All right, so for this next example, it says to simplify an expression with negative exponents. Take the numbers out of it right here. So that would be 3 over negative 36 times. And then we'll go to the g. So I have g to the negative 3 over g to the positive 3 times. And then I've got the h's right here, the h's. So that would be h to the 2nd over h. And I'm going to put a 1 there as a reminder. It's h to the 1st. Times, and now since there's nothing above the j, I got to put a 1 there, so that would be 1 over j to the negative 4th power. Now I need to simplify everything. So over here, we've got 3 over negative 36, and that's going to end up being negative 1 over 12. Then we got a times. And then right here, the rules of division are to do the top exponent minus the bottom. So that would be g to the negative 3 minus 3, and that's going to give me g to the negative 6. Times, and then this next one here is going to be h to the 2 minus 1, or h to the 1st power. And then this last one will just be 1 over j to the negative 4th power, at least for right now. I still have one more step here to get rid of those negatives. Okay, so the negatives that's right here, I don't have to get rid of that. That's just a regular rational number, so I can call that 1 over 12 times. This one right here, I have to put it in its positive exponent equivalency, which would be the reciprocal of g to the negative 6 is 1 over g to the positive 6 times, now the h right here is already got a positive, so I'll just leave it in the numerator. I'm going to put a denominator of 1, just make sure they're all in fractions. And the last one right here, to make this become a positive exponent, we're going to flip it over and make it its reciprocal also, so that would be j to the positive 4, and I'm still going to put a 1 down there like that. And the final answer is just multiplying everything together, so I got the negative, and then I'm going to put my fraction bar. In the top, I've got 1 times h times j to the 4th, which would be just hj to the 4th. And the bottom is going to be 12 times g to the 6th times 1, which is just 12g to the 6th. Okay, for this one, we're just talking about order of magnitude, and that's used to compare measurements and to estimate and form rough calculations. So the order of magnitude of a quantity is a number rounded to the nearest power of 10. So that means you're going to have 10 to some power. Power of 10 closest to 105 million is really 100 million. And 100 million is really just 10 to the 8th power. If you remember scientific notation, you'll notice that we have 3, 6, 8 zeros. In other words, we have 8 movements of the decimal. So the order of magnitude of 105 million is simply 10 to the 8th power. Okay, for the last example here, they want us to apply properties of exponents. The maximum speed of a peregrine falcon is about 90 meters per second. The maximum speed of a garden snail is about 0.01 meters per second, so a lot slower. The question I want to know is how many orders of magnitude as fast as a peregrine falcon is a garden snail? Now, the easiest way to do this would be to do in orders of magnitude powers of 10. Some of you will probably just set it up like this and divide by 90 and come out with some number. I would prefer to say that this one right here is about 100, so I'm going to write that as 10 to the 2nd power, and this one over here is going to be 10 to the negative 2 power, because that's 1/100. So I would prefer to take the snail speed in orders of magnitude -2 and divide it by 10 to the 2nd power, and we'll get 10 to the -2 minus 2, or 10 to the -4th orders of magnitude as fast. In other words, he's going really slow. So if we want to know what that was in terms of how many times fast or slower, that would be 1 over 10 to the 4th, and that would come out to 1 over 10,000. So basically the snail is going about 10,000 times slower.